My dear students, in the previous video, I introduced the topic, 7th chapter, Applications of Differential Calculus in the 12th standard state board syllabus. In the introduction, I have given that what is the velocity of a particle and how to calculate the acceleration of a particle, and also the slope of a curve. Slope of a curve at a point, given point p x comma y. These are the things you have seen in the previous video. And suppose in this video I am going to solve some problems in the exercise 7.1. Exercise in the chapter 7.1, I have solved some problems on the basis of the ideas given in the previous video. See, suppose a particle is moving, the displacement of a particle, the equation of a particle moving in a direction at the time t, the displacement or the moving particle, displacement of a particle at t seconds is given by s of t is a function of t. S is a function of t, that is the displacement of the particle is s and it is given as a function of t. So otherwise it is given by s of t, displacement of a particle. S is a function of t. So the rate of change of displacement is the velocity. I recall once again the ideas I have given in the previous video. The rate of change of displacement, the rate of change of displacement is the velocity of the particle. Velocity of the particle. Rate of change of displacement is the velocity of the particle, moving particle. That is, velocity of the moving particle is rate of change of displacement, that is ds by dt. Similarly, the rate of change of velocity is the acceleration of the particle. This is the velocity, and next one is the rate of change of velocity. The rate of change of velocity is the acceleration of the particle. Acceleration. The rate of change of velocity is the acceleration. That is a of t equal to dv by dt, or otherwise it is double derivative of s, d square s by dt square. Double derivative of the displacement is otherwise called acceleration. When the particle comes to rest, the velocity is zero. These are the things you have seen. The particle comes to rest if the velocity is zero. The particle moving forward if the velocity is positive. If the particle moving backward, then the velocity is negative. And one more idea I am going to give in this video, that is, suppose Tc is the time point between the two time points T1 and T2. See, one more remark which I am going to give, that is remark, one more remark, that is, if Tc is the time point between the two given time points T1 and T2, if Tc is the time point, if Tc is the time points, if Tc is the time points between the time points, if Tc is the time point if Tc is the time point between the time points T1 and T2, Tc, that is T1 is less than Tc is less than T2. Tc is the time point between the two time points T1 and T2, where the particle changes its direction. This is the time point T1 and T2 where the particle changes its direction. See, at the point T1 and T2, the particle changes its direction. Then the total distance traveled from T1 and T2. T1 and T2 are the two time points. Tc is the time point between these two time points T1 and T2. And where the particle changes its direction at the point T1 and T2, then the total distance traveled by the particle at T1 and T2 is modulus of S of T1 minus S of Tc plus magnitude of S of Tc minus S of T2. This is one more idea you have to remember. Tc is the time point between the two time points T1 and T2, where the particle changes its direction. Then the total distance traveled by the particle from the point T1 and T2 is absolute value of distance at T1 minus distance at Tc plus distance at Tc minus distance at T2. This is the idea. From this idea is we are going to use some problems in the exercise 7.1. Okay. Now let us go to the exercise 7.1. Remember this remark also. Next, our exercise problem. Exercise 7.1, first problem. A particle moves along a straight line in such a way that after t seconds its distance from the origin is. A particle moves along a straight line. First problem, a particle moves along a straight line in such a way that after t seconds the distance from the origin is, S is 2t square plus 3t meters. See, the distance traveled by the particle at time t seconds is S equal to 2t square plus 3t, moving in a straight line. Find the average velocity between t3 and t6 seconds. First question is, find the average velocity. Find the average velocity between t equal to 3 and t equal to 6 seconds. T equal to 3. Between t equal to 3 and t equal to 6 seconds. Find the average velocity. Average velocity, we know that average velocity between t3 and t6 is s6 minus s3 by 6 minus 3. That is the average velocity. distance at 6 minus distance at 3 by 6 minus 3. Newton's quotient, it means Newton's quotient, that is equal to S6 instead of 6, t equal to 6, you substitute 2 into t square is 6 square, 2 into plus 3 into 6, this is S6 minus S3, 2 into t equal to 3, 3 square plus 3 into 3 by 6 minus 3. This is equal to 6 square is 36 into 2, 72 plus 18 minus 9 into 2, 18 plus 3 3s are 9 divided by 6 minus 3 is 3. This is 72 plus 18, 90 minus 27 divided by 3, that is equal to 90 minus 27 is 63 by 3, 63 by 3 is 21 meter per second. This is average velocity, 21 meters per second. This is the first problem, first subdivision in the first problem. Average velocity between S3 and t equal to 3 and t equal to 6. Next question in the problem is find the instantaneous velocity at t equal to 3 and t equal to 6 seconds. And next find the instantaneous velocity at t equal to 3 and t equal to 6. Next question is find the instantaneous velocity, or not average velocity, instantaneous velocity. Find the instantaneous velocity. Find the instantaneous velocity between t equal to 3 and t equal to 6. Instantaneous velocity is ds by dt. That is limit of Newton's quotient. Limit extends to 0. F dash of x is instantaneous velocity. Instantaneous velocity is ds by dt. What is s? This is 2t square plus 3t. ds by dt is 2 into derivative of t square is 2t plus 3 into derivative of t is 1. Derivative ds by dt, t square derivative 2t plus derivative of t is 1. So instantaneous velocity ds by dt equal to 4t plus 3. Now instantaneous velocity at t equal to 3. Instantaneous velocity at t equal to 3, that is ds by dt equal to at t equal to 3. 4 3s are 12 plus 3, 15 meter per second. Velocity at t equal to 6. Instantaneous velocity at t equal to 6 is ds by dt 4 into 6 plus 3. 4 6 are 24 plus 3 27. 27 meters per second. That's all about the second subdivision of the problem. That's all about the first problem in the exercise. This is instantaneous velocity. Derivative of s with respect to t. And next, second problem in the exercise. Second problem in the exercise, a camera is accidentally knocked off an edge of a cliff 400 feet high. 400 feet high. A camera is accidentally kicked off an edge of a cliff 400 feet high. This is a cliff. This height of the cliff is 400 feet. 400 feet high. From the top, a camera is accidentally knocked down. The camera falls a distance of s equal to, the camera falls at a distance of s equal to 16 t square. X equal to 16 t square in t seconds. Camera falls from the 400 feet height cliff, whose equation is s equal to 16 t square in t seconds. Our required problem is how long does the camera fall before it hits the ground? How long does the camera fall before it hits the ground? See, height of the cliff is 400 meters. Since it is a falling down, the equation of this minus 16t square is minus 400. Because height of the cliff is 400, from this is the ground. 400 feet height. See, since this is falling down, negative symbol is given. Minus for falling down. Minus 16t square to minus 400. From this, what do you get? How long, my first question is, how long does the camera fall before it hits the ground? The distance they are asking. First problem, first subdivision, how long it will take for falling ground? That is, t square equal to what from this equation? Both are negative terms. T square equal to 400 by 16. Therefore, t equal to square root of 400 is 20. Square root of 16 is 4. That is equal to 5 seconds. So, how long? It will take 5 seconds to reach the ground. The camera takes 5 seconds to reach the ground. This is the first problem. How long it will take? It will take 5 seconds to reach the ground. Next question is, what is the average velocity with which the camera falls during the last 2 seconds? What is the average velocity with which the camera falls at the last 2 seconds? The total time taken is 5 seconds. Last 2 seconds means this is 3 seconds you will take. This is last 2 seconds. Totally 5 seconds. Total 5 seconds. After traveling 3 seconds, last 2 seconds, this is 2 seconds here. Average velocity for last 2 seconds they are asking to reach the ground. For that average velocity, second subdivision, average velocity in last 2 seconds is equal to total time taken is S5. This is 5 seconds, totally it will take 5 seconds. So S5 minus S3. S5 minus S3 by S5 minus S3 by 5 minus 3. This is your average velocity. Sorry, average velocity. Yes, correct. Average velocity is total time taken is 5 seconds and it travels 3 seconds because they are asking last 2 seconds. 5 seconds S5 minus S3. That is S5, what is S5? This is equal to this is 16t square. 5 square 16t square minus S is 16 into 3 square. S5 minus S3, 16t square minus 16 into 3 square by 5 minus 3 is 2. This is equal to 5 square is 25 into 16. 25 into 16 is 400 minus 9 into 16. 16 into 25 400. 3 square is 9 into 16 144 by 2. That is equal to 400 minus 144 is 6, 9 minus 5, 2. 256 by 2, that is equal to 128 feet per second. 128 feet per second is average velocity after 2 seconds. In the last 2 seconds, the average velocity in the last 2 seconds is 128 feet per second. That's all about the problem. Okay? And I will stop here and we will continue the exercise in the next video. Thank you.